In our last video, we tackled the power rule, one of the simplest yet most essential tools in calculus. If you can handle derivatives of basic powers like x to the power 5, then you're off to a great start. What if you're dealing with a more complex function, like a function in another function? That's when the chain rule comes into play. The chain rule is key to handling derivatives of composite functions. So, what exactly is the chain rule? Well, it's a method used to differentiate composite functions. You can think of it as peeling back the layers of an onion, one at a time. Here's the basic formula. So, all this means is for you to get the derivative, differentiate the outer function first, then the inner function later, and then multiply them together. Remember how the power rule entails just bringing down the power of n and subtracting 1? Well, the extra bit for the chain rule is you must multiply by the derivative of the inner function as well. Let's see how this works with 3 examples. Example number 1. Differentiate the function y equal to x plus 5 all to the power 4. Alright then, so we need to start by identifying the inner function, which is x plus 5. And then differentiate it just using the power rule by bringing down its power. So we ignore the x plus 5, which is in there. Then we bring down the power 4. And then now we can minus 1 to get 3 in the exponent. Now we differentiate the inner function, which is x plus 5. Definitely our derivative will just be 1. So when we multiply them, we're just going to have dy by dx, which is 4 times x plus 5 all to the power 3. Example number 2. Differentiate the function y equals sine of 2x plus 1. So once again, we start by identifying the inner function, which is 2x plus 1 in this case. So it means that the outer function would just be sine of x. And the derivative of sine of x is just cos x. Alright then, we go ahead and differentiate the inner function, which is 2x plus 1. And that would just give us 2. We then substitute into our formula, and then our final answer would just be 2 sine 2x plus 1. Example number 3, an exponential function. Differentiate the function y equals e to the power 3x squared. The inner function in this case would be 3x squared. It means that the outer function would simply be e to the power x. And remember, for you to differentiate e to the power x, you get e to the power x, right? So the derivative of e to the power 3x squared would just be e to the power 3x squared. So it stays unchanged. Now, let's move on with the inner function. We have 3x squared. So for us to differentiate this, we use the power rule by bringing down the 2, then subtracting 1 to get the derivative. This would just be 6x. Lastly, we substitute into the formula for the chain rule by multiplying both results together. And this will give us our final answer, which is 6x times e to the power 3x squared. That's it for today's video. If you found it helpful, make sure to give it a thumbs up and watch the next video on the product rule. As always, make sure you master the chain rule with practice.